So now we're starting to look at a new shape, which is called an ellipse, and we're going to break this into two parts, just like with a lot of the other ones we do. So the definition of an ellipse is the set of all points whose distances from two fixed points, which we pronounce either foci or foci, either way, has a constant sum. So what they're telling you is that there are two locations on this graph. You can see them marked here and here. For any of the points that make this kind of long oval shape around it, if you picked a point on it and then added the distance to the first one and the second one, that total length will be the same for any point going all the way around. So if I picked another point like right down here, for example, if I added this distance plus this distance, it will be the same as the first two that I drew in there. So this shape has a lot in common with the circle we were just looking at in the last section. And one of the most important things for dealing with a circle is being able to define the distance from the center to the edge. And for a circle, there's only one length. It's the same all the way around, and we call it the radius. For this shape, it's kind of like we have two different important ones for us. There's the longest radius, which is going to be defined by the variable a. So that's like our long radius. And then there's the shortest radius, which we will define as the length b. So when we're looking at our formulas, it's helpful to understand what the a and the b are referring to. I like to define them as the long radius and the short radius. So here you can see that we have lots of different formulas listed out again. I will be trying to avoid making it something that you have to memorize in terms of h plus or minus a. It's just a lot of information to try to memorize. Instead, I like to focus on the meaning of the concepts for the a and the b values and how they affect the graph. So starting from the very beginning, you'll notice these formulas have a lot in common with the formula for a circle that we just looked at. The main difference is that now we have a fraction. Instead of just the x minus h squared and the y minus k squared equals r squared, we now have the other side of the equation has to be set equal to 1. And that is very important. If you ever see another number over here, like a 47, then you need to divide everything by whatever number you see on the other side so that this becomes a 1 and you end up with a denominator for everything else. Beyond that, there's really not too much of an importance between whether you write the x squared first or the y squared first. What really matters the most is that a is always the bigger value, and that's what this is defining up here at the top. A is defined as bigger than b. So when the bigger number is underneath x, that means your ellipse will be stretching more to the left and to the right. And when your a value is underneath y, then that means your ellipse will be stretching more vertically than to the left or to the right. Sometimes you will be asked to identify the location of the foci, and we don't really need to draw them in our graphs very often. They're kind of just like the objects inside the ellipse that the ellipse orbits around. However, if you do need to identify those precise locations, you can use this Pythagorean relation that I've given you down here, because a squared and b squared can be determined from the original formulas. So the tip I give you is try to arrange the equations so that the bigger denominator comes first, and that way it'll be easier for you to say, okay, if I have a bigger number underneath x, then x goes out front. If I have a bigger number underneath y, then y goes out front, and it'll make it easier for us to compare our answers and compare notes on things. However, there are some textbooks that do not necessarily always put a first. They just always write x and then y. So different textbooks may put their answers in different orders. So here you can see one of the most common types of examples will be them giving you the formula, and it's not in the correct form yet, but they're going to say find the vertices and the foci of the ellipse. Well, the first important rule I was going over for you guys is we have to set this other side of the equation equal to 1. So since I have a different number here, I need to divide everything on both sides of the equation by 36. And then I'm going to reduce those numbers to get our standard form. So what happens here is 4 over 36 will reduce. That means I now have x squared over 9 plus, and then for 9 over 36, this will be y squared over 4. And since I did 36 divided by 36, that gives me the 1 that I needed over here on the other side of the equation. So always just divide by whatever number's on the opposite side to turn this right-hand side of the equation into a 1. Now, as with the other shapes, once I get the standard form set up, I like to go through and identify all of the information that's in front of me. For example, I don't see a number being added or subtracted from my x value, which means that h is equal to 0. I also don't see a number being added or subtracted from the y value, so that means k is also equal to 0. For the denominators, a is always the bigger one. So if this is a squared, then that means a must equal 3. So just take the square root of the bigger number for a. And for the smaller number, take the square root of that to find b. The only other number we can't find directly is the c value. And to find that one, let me point you back to the formula we had in the last slide. If we use the fact that a squared equals b squared plus c squared, then we can solve this to subtract 4 from the other side. And then you could take the square root of both sides as well to get plus or minus root 5. So now that we've listed out all the variables, usually the starting point is to state what the center of your shape is, whether it's a circle or an ellipse. This is a handy place to begin because a lot of things are going to be based on that coordinate. Well, in this case, we said h and k were both 0, so that means the center of this ellipse is 0, 0. Now I can go on to the vertices. The vertices are the endpoints on the longest distance. So they use the a value to determine their locations. So if we started from the point 0, 0, and then we went a distance of a, and in this case, since a is underneath x, we're going to be adding it and subtracting it from the x value. So we're going to add and subtract that a number to the x value. So my vertices for this one, 0 plus or minus 3, comma 0. If the bigger number had been underneath y, then I just would have been adding and subtracting it from the y coordinate instead. And it's nice and easy when the number you're adding and subtracting to is a 0, but you will have to compute them when you have other numbers out there like 5 plus or minus 3. Make sure you simplify those two different answers. And then the last thing they wanted was the foci of the shape. Well, the c value is going to be added and subtracted to the exact same variable. So since a was added to x, c will also be added to x. So for the foci, starting from the coordinate 0, 0, I am adding and subtracting root 5. If you were confused by any of those additions and plugins I was making, it's all just coming from the information on the previous slide. So for the vertices, I started off with my h and k values 0, 0, and I added and subtracted the a number to the x coordinate. So it became 0 plus or minus 3. And for the foci, it was the same thing. I found what c equaled, and then I added and subtracted that root 5 number to the h value, which was 0. So that's where all the answers came from, if you'd like to look at this more from the formula. Now, drawing the graph of these is actually pretty simple, especially when it's a multiple choice case like this. So the starting piece of information we want is the center, because that'll help us determine h and k. I can tell that the center of this graph seems to be at approximately 1, negative 2. So if the center is 1, negative 2, then for my x plus or minus number and y plus or minus number, remember the sign should flip. That means I should see an x minus 1 and a y plus 2. So this answer is out right away. This one seems okay. This one's out, and this one's out. So actually we only have one choice out of those available. But the second thing I was going to show you was the fact that this graph was stretching more to the left and to the right, and it looks like it's going a distance of 3 from the center. So if a is equal to 3, I know it's going to be underneath the x variable, and I know it's that number squared. So underneath the x's, I should have seen a 9, and only these two showed a 9 underneath x. So that would have had it narrowed down to choice B from there. If you're drawing the graphs on your own, the process is still pretty similar. You want to start by identifying the center. So in this case, my center is at the point 2, 1. So I'm just going to draw a dot in there for a moment. And then the number underneath y is a 9, which means if you take the square root of this, I need to go 3 in the y direction. So up 3, I'm going to draw a dot there, and then down 3, draw a dot down there. And the reason I'm going up and down 3 is because that 3 number is attached to the y variable. In the x direction, since it's a 4 underneath my x, the square root of 4 is 2. So in the x directions, I need to go right or left 2. So you can see that this has kind of made my football shape for me. You just need to connect these together closely enough to resemble an ellipse. So pay attention to which number is underneath which variable and use that to start from the center and extend in those directions. And that way it's also a lot easier to actually identify things like the vertices by drawing the graph on your own and then just identifying which coordinates you have labeled. So that'll be it for the first part of this section, being able to label and identify pieces of information from an ellipse and being able to draw those graphs or identify them on your own.